Let's look at the type checking of expressions. So type check expert takes expression, it takes a list of class declarations, it takes the type for this and the type for arg. And we'll find it helpful to have a recur function that just takes the expression and recurs with the same classes this and arg. Looking at all the different expression types now, these are again the types of expi because we're reusing that grammar. If we've got a numi, clearly the type is numt. If we've got an argi, then arg type is already exactly the answer, and if we've got a thisI, then this type is exactly the answer. If we have a plus or a multi expression, then we need to check that left and right are both numbers, and then we get a number type. And so we've got a little helper type check nums right here that does that. Make sure that the left type is num, make sure the right type is num. If both of them are, then numt is the result type. Otherwise, we complain about either the right or the left not being a number. NewI gets into the class-oriented part. So we've got NewI, a class name, and we have a list of expressions for the field values. So the first thing we can do is, we've got expressions, so we can recur and type check all of those expressions, and then we get the argument types, that is the types of the actual arguments to instantiating the class. We're going to need to compare that to all the field types of the class. And we can't just extract that directly from the class because a class might extend another, which has its own fields and so on. So we'll have getAllFieldTypes, which will be a helper function that'll get all of those field types for us. So what we expect to get back is a list of types for all the fields of a class. And then all we have to do is make sure that the length of our actual argument types, which matches the length of the number of expressions, matches the length of the expected field types. If not, we'll complain. If they do match, then we can do a mapping over those and make sure that they all add up. So we can check that that's what map2 is. It's going to create a list of booleans for us. So for every argtype and field type, we'll check not necessarily that the arg is exactly the field type, but here again is where is subtype comes in. It makes sure that the type of the actual argument is compatible with the field type. That is, if the argument type is a subtype of the field type. So this gives us a list of booleans back, and then this foldel here walks over that list and ANDs them all together, and so we'll get true back if all of them are true. So if all of them are true, then what type do we want to return here for the NewI? That means we're instantiating a class with suitable field expressions, so we should get an object back, and the object instantiates that class, so that's why we say obj of that class name. So that's NewI. Let's look at getI. GetI has an object expression and a field name. This expression, we should type check it, and we hope to get an object type back. If we don't get an object type back, then we complain with the type error. If we do get an object type back, then we know what class that object instantiates, either this class or a subclass at least. But we have to assume no more than that it's a subclass, that it's an instance of this class. And so if it's an instance of this class, then we can take that class name and get all of the fields from that class. Again, looking in superclasses and so on. So this is one of our find in tree functions. And that should give us the type corresponding to this field name. And if we get that type, then that's exactly the type we wanted. That's the type of the value that getI will return. On the other hand, if we don't find that field name, then find field in tree should raise a type error saying that the field name is not there. So find field in tree both checks that we're getting a field that we know will be in the object and reports what the type of that field is. SendI is going to be kind of similar because we've got an object expression and a method name. So we're going to type check the argument expression, and we hope that we get an object type back. Also argument, the actual argument is an expression, so we will recur and type check that to get the actual argument type. Now that we have an obj type here, as long as it's an obj, then that means we know the class that will have the method that we're calling. So then we can go type check ascend to that particular method and that particular class. And we have an argument expression, and we pass that along just for error reporting because what matters is the argument type. But if this type doesn't match what the method is expecting, then we want to report an error related to that expression. And then in the process of type checking this, we may need to consult the class declarations. After all, we'll need to find class name and find the method that is declared in that class. We'll come back to typechecking, but just to point out the obvious, super is also going to call typechecking. Because with super, we have only a method name, but we know the class name because this class is based on this type. So this type should be an obj type. We can just assume that because we're always going to have an object type for this. So we can go find that class. And we need to make sure it's not about whether this class has that method, but the reason we found the class is so we can get the superclass name. So getting that superclass name, now we want to make sure that in that superclass we can call this method with that argument expression that has that argument type, perhaps consulting the list of classes. So both sendI and superI rely on typechecking. Typechecking finds the method for that class with that method name. That method will have a declared argument type and result type. It'll have some body expression, but that's not our problem. That's already been checked. What we want to know is the type of the actual argument that we supplied, if that's consistent with the type expected by the argument of the method, which is argtype him. And of course, these don't have to be exactly equal. The actual argument needs to be a subtype of the expected argument type. So we use is subtype here. If it's all consistent, then the type that is produced by calling the method, that corresponds to the declared method type. And if not, then we report a type error.